Hi GOH, this is Unit 3, Lesson 8, and today we're going to talk about another method of proving triangles congruent, which is angle-side, so AAS, and we're also going to talk about isosceles triangles. So far we've seen three ways to prove triangles are congruent, and that was side, angle, side, angle, and side, side. So this lesson is all about angle, side. What does angle, side look like? Basically, you have two triangles, and you have an angle and a side of one triangle congruent to an angle, and a side of another triangle. Okay, so two angles and a side of one triangle are congruent to two angles and a side of another triangle, then the two angles are congruent. Those two triangles have to be congruent. Here's why. In exercise 1, we know that AC is congruent to DF, and that's already marked on our picture for us. We know that angle B is congruent to angle E, and angle A is congruent to angle D. And they're asking you, why does this not represent an angle-side angle scenario? Well, remember, in an angle-side angle, the side has to be between the two angles, and that is not true here. So in angle-side angle, the side is included between the two congruent angles. And that is not here. Here we have the two angles and then the side after the fact. But we're going to do a short proof to show that if you're given that angle A is congruent to angle D and angle B is congruent to angle E, then angle C and angle F have to be congruent. Basically, think about what you know about the three angles of a triangle, like the measure of angle A plus the measure of angle B plus the measure of angle C. What does that actually equal? Remember, all three angles of a triangle equal 180 degrees. And the same would be true for triangle DEF. The measure of angle D plus the measure of angle E plus the measure of angle F equals 180. The reason is angles of a triangle equal 180. This is a short proof, but it is 4 steps and there's not a lot of room here, so I'm going to write small. Now, because both of those equal 180, I'm going to use substitution. So I'm going to have a measure of angle A plus a measure of angle B plus a measure of angle C. But instead of saying it equals 180, I'm going to say it equals angle D plus E plus F, because angle D plus E plus F also happens to equal 180. So since they both equal 180, they have to be equal to each other. And that's going to be substitution. Usually I write my given first, and I didn't, but that's okay. I'm just going to write it right now. The measure of angle A is equal to the measure of angle D, and the measure of angle B is equal to the measure of angle E. That's my given. And basically, I'm going to subtract out the A and the D, and I'm going to subtract out the B and the E, and I am just left with C and F. So the measure of angle C is equal to the measure of angle F. Now, normally on a proof you wouldn't cross off like that. I just did it so you guys could see it. So once you know that two angles of one triangle are congruent to two angles of the second triangle, those third angles have to be equal to each other, because both triangles add up to 180. So if you have the two angles congruent to the two angles, there are only so many degrees to go around. Those last angles wind up being congruent to each other. Now, why must the two triangles be congruent to each other? They're congruent to each other by angle, side, angle, because now I have this third angle. I know angle C and angle F are congruent, so the triangles are congruent by angle, side, angle. Since all pairs of corresponding angles are congruent to each other, all corresponding angles are congruent, angle, side is just an extension of angle, side, angle. So angle, side is really just an extension of angle, side, angle, and the fact that the angles of a triangle equal 180. Okay, but angle, side is another way to prove triangles are congruent to each other. We had angle, side angle, and now we've shown that angle, angle, side is just an extension of that, so we can use that. We don't have to go through the trouble of saying the third angles are congruent and calling it angle, side angle. All right, so here's our proof, our next proof that we're going to do. So we have statements on the left, reasons on the right. I know that AC bisects angle DCB. If I'm bisecting an angle, I'm going to have congruent angles as a result. And I know that angle B is congruent to angle D. So that's my given. I'm going to write that in step 1. AC bisects angle DCB, and angle B is congruent to angle D. So angle B is congruent to angle D, and AC bisects angle DCB. So I'm going to go to DCB and highlight it. That was just cut in half because it was bisected. So I'm going to call this angle 1 and angle 2. An angle bisector cuts an angle in half. So once I know that something's an angle bisector, I'm going to call those two halves. I just easily call them angle 1 and angle 2, and I say they are congruent to each other, and the reason is just definition angle bisector. Keep it simple. Now, ultimately, I'm trying to prove that BC is congruent to DC, but in order to do that, you're always first proving the triangles are congruent. Are these triangles congruent? Well, I have two angles. I need a side. There's no other given, but remember I said that the two things you have to look for vertical angles, and you have to look to see if they share a side. If they share a side, that will not be in the given. It'll be something that you have to recognize. So AC is congruent to AC reflexive. Now the triangles are congruent by my new method that we just learned, angle, angle, side. So triangle ACB is congruent to triangle ACD by angle, angle, side. And remember, once the triangles are congruent, the rest of the corresponding sides and angles are congruent. So I can say that BC is congruent to DC, and that is my CPCTC. All right. We have another proof on the back. All right, if you want to flip this over. Actually, we have two more proofs. So we studied the properties of isosceles triangles in Unit 2, but we will revisit them now with an angle side at our disposal. We will first prove that the base angles of an isosceles triangle are always congruent. That's something that you probably learned in middle school, but you didn't prove it, so we're going to prove it right now. The base angles of an isosceles triangle are always congruent. In the diagram below, isosceles triangle ABC has been drawn such that AB is congruent to AC. All right, so these are congruent. And the angle bisector of angle BAC has been drawn and intersects BC at D. Prove that angle B is congruent to angle C. So basically, if I can prove that these triangles are congruent, then I can say that angle B is congruent to angle C by CPCTC. So my goal is to say that the triangles are congruent. And I know that AB is congruent to AC. And I also know that I have an angle bisector, BD bisects angle BAC. That was all in the given. Well, we just had an angle bisector on the other page. If I'm bisecting an angle, I am cutting this angle in half. So angle 1 has to be congruent to angle 2. An angle bisector cuts an angle in half. So the result is you have two angles that are congruent to each other. Name the two angles, say they're congruent, and the reason is definition angle bisector. I don't know why I wrote that. Definition angle bisector. Now remember, I'm trying to prove that my triangles are congruent. Therefore, look what I have. They share that side. So AD is congruent to AD, reflexive. Now look at your picture. Do you have one of the methods that we've learned to say the triangles are congruent? You sure do. Triangle BAD is congruent to triangle CAD by side angle side. Once the triangles are congruent, the rest of the corresponding sides are congruent, and the rest of the corresponding angles are congruent. So now I can say that angle B is congruent to angle C by CPCTC. Angle B and angle C are the base angles of an isosceles triangle. So we have just shown that if two sides of a triangle are congruent and it's an isosceles triangle, then those base angles will also be congruent. And although it might seem obvious, we should also prove that if two angles of a triangle are congruent, then the sides opposite them are congruent. So we just proved if the two sides are congruent, then the base angles are congruent. We're going to prove the reverse. If the two base angles are congruent, then those sides opposite those angles will also be congruent. So that's what we're doing here in exercise 4. So we're going to use the same diagram. We have triangle ABC, but all we know is that angle B is congruent to angle C, and the same thing that I had before in that BAC is an angle bisector. Whoops, let me get this color. So that would also, just like before, make angle 1 and angle 2 congruent to each other. So I know that angle B is congruent to angle C, and AD bisects angle BAC. Just like before, I'm going to prove that my two triangles are congruent to each other. If my two triangles are congruent, then the rest of the corresponding sides and angles are congruent to each other. And then I can say that that triangle, once I get BA congruent to CA, then I can say it's isosceles. My given's a little bit different, but not really. I still have an angle bisector. If I bisect angle BAC, angle 1 is congruent to angle 2. Definition, angle bisector. I still have AD congruent to AD. Reflexive. Now you want to mark your picture because yes, the triangles are congruent to each other, but the reason is different. My given was a little bit different, so my reason's going to be different. This time, triangle BAD is congruent to triangle CAD by angle, side. But once they're congruent, that means that the rest of the corresponding sides and angles are congruent. So I'm trying to prove this is isosceles. That means I need this side and this side to be congruent to each other. So BA is congruent to CA, CPCTC, and once I prove those two sides are congruent, then I can say triangle ABC, the outermost triangle, is isosceles. Why? Well, that's the definition of isosceles triangle, is if I have two sides congruent, and I do. I just showed that BA is congruent to CA. All right. So that was a proof, but let's do an actual problem. So in exercise 5, I know that BD is parallel to AC. Okay, so that right there means parallel. This is how I mark parallel. It looks like a little greater than sign. AB is congruent to AC, so AB is congruent to AC. And the measure of angle BAC is 78. That's on my picture. I don't know if you guys can see, but this right here, BAC, is a triangle, and it's not only a triangle, it's a special kind of triangle. These two sides are congruent. That makes it an isosceles triangle. So AB is congruent to AC. It's an isosceles triangle. Let me put some numbers in here. I'm going to call this angle 1 and angle 2. Therefore, angle 1 is congruent to angle 2. We just proved that up above. You know that the three angles of a triangle equal 180. So these are congruent to each other. All right. Let's take 180, subtract the 78. That's called my vertex angle. I have 102 degrees, but that's to split. Angle 1 is congruent to angle 2, so I'm going to take that 102 and divide it by 2 is 51. All right, so I'm trying to find the measure of angle DBC. Whoops. So DBC is actually this angle out here. I'll put like a little green dot here. DBC is this angle. Can you guys remember, why did they even mention that these were parallel lines? If these are parallel lines, then this angle here, DBC, which I'm trying to figure out, is actually equal to angle 2, and I just found out that angle 2 is 51. So DBC is equal to the measure of angle 2 because they are alternate interior angles. Everything is tied together here. So therefore, it equals 51 degrees.